All right, so we're looking at 8.3 day one, the surface area and volume of prisms and pyramids. This is a bit of review for some of you from grade 8. And what I want to start off with here today is not surface area of the volume of prisms and pyramids, but rather I want to start off with a question that will be a good review for you for the exam. So please take a look at this question. You're determining the equation of the line that passes through 2 points, 4, -5 and -6, 11. The key here is you're going to answer in standard form. So make sure that you're answering in standard form. That might be the challenge for some of you. And then you have to identify 2 other points on the line. Okay, this is a tough question, but if you can do this, it's great. As a good sign that you're getting set for the exam and you're in pretty good shape. For those of you who have any difficulty with it, I'd like you to try your best. Keep your work neat and organized. Remember, I would start working right over here on the left side. Maximize your space and work your way until you get to the end and have your final answer. So maximize your space, be neat, organized, and pay attention to communication. We'll take it up in class together, but I'd like to see at least an attempt if you're having difficulty with it. All right, the learning goals. The surface area is expressed in square units, whether they be centimeters, square centimeters, sorry, square millimeters, square meters, etc. I can calculate the surface area of a pyramid, volume of a pyramid, surface area of a prism, and volume of a prism. You might recall that a pyramid has a shared vertex, okay, and a prism has the same base and a same top and bottom, basically. Base and the top are the exact same. All right, so let me look at the volume. Let's look at the formula for volume of a prism and the formula for volume of a pyramid. So the volume of a prism, again, is area of the base times the height. So in this case, we have that area of that base times how tall it is will give us the volume of this, okay? The volume is calculated in cubic centimeter or cubic units, okay, where area is calculated in square units. The reason why we say the volume is cubic units, I can say units cubed. Again, units is just generic, right? That could be centimeters, millimeters, or kilometers or meters cubed. The area of the base, when you're calculating area, as it says in the learning goal, area is square units. Area of the base is really length times width. So that's really 2 dimensions, right? We've calculated 2 dimensions, length and width. And then we're also multiplying that by height. Remember, if there's 2 dimensions, we'd say squared. That's where the 2 comes from. If it's 3 dimensions, length, width, and height, that's where we get the 3. It's 3 dimensions. And if you only measured one of those, for example, if we just said we're only measuring the length, then of course that would just be, for example, or what do you say, units, just units. And there's an imaginary 1 on it. It just means one-dimensional. You only have length. There's no width and no height. Okay, so just to point that out, that's why it's cubed units. Now we have the formula for the volume of a pyramid is a little bit different. This is 1/3 the area of the base times the height. So you notice how they both share area base times height, but then here we have 1/3 the area of the base times height. And I try to show you here on the right hand side why that is. So basically, if I try to draw in red the same prism that you have here, I try to draw that in red here. Basically, if you had a block the size of that prism and you try to slice out a pyramid out of it, you would end up with 1/3 of the volume of that original prism if you carved out a pyramid with this, if it has the same base, same height, so basically the same dimensions, and I basically come here and I carve out, if I carved a pyramid out of this, like that, if I carved a pyramid out of there, that pyramid in red would be 1/3 of the volume of the entire prism. Okay, and that's why the formula is 1/3 area of the base times height. Kind of neat. If you really want to test it out, you can, some examples people use are filling this up, having a hollow pyramid inside there, filling it up with rice. Turn it upside down, fill it up like a cone, and you'll realize that it holds 1/3 of what the entire prism will hold, or a box would hold. All right, now we're determining the surface area of each object. So, and then we're going to determine the volume of each object as well. So the surface area here, I want to color coordinate this for you. So we're going to first calculate the surface area of this side right here, the right and the left. Those have the exact same dimensions. They are 8 times 10, okay? So the first thing we'd write is 8 times 10, and that would be 80. but we have two of them. There's a left side of that prism and the right side. So 80 in this case times 2, which is 160. Then we are going to color coordinate the top and bottom. And so we're going to have this part right here, and of course the base, so the base and the top. And those two have the exact same dimensions as well, and they have the dimensions 8 by 8. So let's go ahead and put that in 8 times 8, which is 64. And we'll say 64 twice because there's a top and a bottom, and then you get 128. All right, and we're off to here. Let's turn to green, and we're going to erase that. And now we're going to do the front and back. So the front would be this portion here. Oh, maybe I have to do the back first. The back is, of course, that whole part back in here, back in there. And then the front is obviously this portion right here in the front face. Those have the exact same dimensions. That's also 10 by 8. So we're going to go ahead and put that in, show our work. 8 by 10 equal 80, and that's times 2, which is 160. And then we want to add everything together. The 160 and 160 is 320 plus 128. That's 448, I believe. 320, 420, 30, 48. 448. All right, so let me put that back. Total surface area equal 120 plus 120. I don't know where I'm getting the 120 from. It's 160. So 160 plus 160 plus 128, which is equal to, we said 448, I believe. 320, 420, 48, and it's squared centimeters because we're given the units. All right? Now we have to calculate the volume. The volume is pretty simple. It's just area of the base times the height. So the area of the base, I'm going to show it this way, area of the base times height, or area of the base h. You can do that if you like. Area of the base times the height. In this case, the area of the base is 8 times 8, and the height is 10. So 8 times 8 times 10, and that gets us 64 times 10, which is 640, and that would be in cubic centimeters. Remember, because it's 3 dimensions. There are length, width, and height. Okay, we're going to do this pyramid together, and then I'll let you do the other two on your own. In this case, we are calculating the volume of the surface area and the volume. To do the surface area, I want you to be able to picture this. Really, you have a square on the base, and then you have 4 triangles. Now, those would fold together to come to the peak and create a pyramid. So we technically have one square base. I'm going to erase this right now. And we can show our work like this if we'd like. Area of, it'd be better to blow that up a little bit. Area of the square is going to equal length times width. And the length of that square, or length and width of that square, 8.5 times 8.5. 8.5 times 8.5 equal. Then we also have the area of the 4 triangles. So we're going to say area of triangle and is equal to base times height divided by 2. And one triangle has a base of 8.5 centimeters, and the height is given to us there, which is 12.2. Divide that by 2, and then we're going to multiply this whole thing by 4 because there are 4 of them. But if we're doing that, we remember we can cross reduce. 2 divided by 2 is 1. 4 divided by 2 is 2. So we're really going to multiply 8.5 times 12.2, and then we're just going to multiply that by 2. Okay? And we're going to say, let's get to our calculator here. And it was base times the height, which is 12.2, and that was also times 2. 8.5 times 2, so 207.4. So this is equal to 207.4, and that would be squared centimeters. And then we have to calculate the area of the base, and then we can say all this plus 8.5 times 8.5, and that's 279.65. 279.65 we said, right? Trying to erase that. Sometimes it doesn't work. That keeps popping up. All right, so forget that. And there we go. 8.5 times 8.5. 72 and a quarter. 72 and a quarter. So this is, move this over here. And the area of the square, so we'll say the total. They have some room here. Total area, or total surface area, I should say, is 72 point, oh sorry, that was 72 and a quarter, I think. I put 72 and a half, apologize. So that should be a quarter. And this is 72 and a quarter plus 207.4. That's 279.65. Oops. 279. All right. 279.65 squared centimeters. All right. So there are the calculations. We want to do the last thing here is the volume. So the volume, and we remember from the formulas up above, is 1/3 area of the base. I'm just going to erase that, make it a capital. 1/3 area of the base times height. Okay. Sorry for my chicken scratch there. That should be better. Area of base times height. Okay, and so 1/3 area of the base is equal to 1/3 area of the base was 72.25. We have that above, times the height. How do we find the height of the entire pyramid? You're tempted to say that it's a 12.2, but it's not actually 12.2. Really what we have to do is find out the height of what goes right down the center there and comes out to the side. How do we find that right there? Well, we can also look at it like this. We have that given there, and I'm going to go straight up the middle. We already have the slant, or the hypotenuse, is 12.2. So if I know a squared plus b squared equals c squared, in this case, I know what c squared is, and I know that the base is going to be half of 8.5, and then I've got to find the height. So what we could do is rearrange our formula and say c squared. Let me erase that as well. So I'm going to say c squared minus a squared equal b squared, and then b squared, b will equal the square root of c squared minus a squared, which is really, b is going to equal the square root of half of 8.5, which will, c squared is 12.2 squared, 12.2 squared minus, and then half of 8.5 is 4 1/4, 4.25 squared. And we can use our calculator to do a lot of the work for us. So that's 12.2 and 4.25 we said, right? So let me delete that. That's the square root of 12.2 squared minus 4.25 squared. 11.4, we'll round it to 11.44. So the height is 11.44, or b is 11.44, and then we're going to use that right here. We multiply by height and say 11.44, 72 1/4 times 11.44. 72 1/4 times 11.44, that didn't work. 72 1/4 times 11.44 divided by 3, which is really multiplying by 1/3. And it's 275.51. 275.51 equal 275.51, and that's cubic centimeters. Okay? All right, you're working on the last couple on your own. Good luck with that, and we'll see you in class.